For most of us, the foundation of our networking is done over copper cabling. If you want your network to run well, then you want to be sure you're using the right kind of cabling and that your cabling infrastructure is working exactly as expected. If you're building out a new area and you're putting in fresh cabling, then you want to be sure all of that cabling installation is done exactly to specification. Most of what we do on our networks are going to be using these copper cables, so we want to be sure that everything works perfectly. If we look inside our cables, we'll see that there are different pairs of cables that are twisted around each other. These are twisted pair cabling. These are using balanced pair operation, which means we're sending the same signal over each one of those pairs, but one of those signals will be positive and one of those signals will be negative. It's this twist that allows us to receive information over this cable even when there might be interference. That's because this twist will be constantly moving away from any interference as the signal goes through the wires. We can compare these opposite signals on the other end of the wires to see exactly what the value should be. Additionally, you'll notice that the different pairs will also have different twist rates. This means we'll have a different set of values across different pairs, even if they are subject to the same interference as the signals going through. One of the most popular types of twisted pair cabling is the unshielded twisted pair, or UTP. And you can see in this picture, this UTP has no additional shielding around either all of the pairs or any individual pairs. You can also get cabling that is shielded twisted pair, or STP. This additional shielding helps protect against any additional interference. There may be shielding on the overall cable, and there could also be shielding on individual pairs of the wires. You'll find that shielded twisted pair also includes some grounding wire, so you can make sure that this cable is properly grounded. If you're to look at the specifications of the cable or even the printing that's on the side of the cable, there will be a number of abbreviations that could be used. If it's an unshielded cable, it will have a U specifying that this is unshielded. One that has an S will mean that it is shielded, but it will be a braided shield, and a foil shield will be specified by placing an F as part of the cable type. You'll see this spelled out showing the overall cable shielding. There'll be a slash, and then there'll be the shielding type for the individual pairs, and then a TP to specify the twisted pairs. So if a cable has a braided shield around the entire cable and then a foil around each of the individual pairs, you should see S/FTP on the side of the cable or the box the cable comes with. If the shielding is like the picture here where there's foil over the entire cable but no shielding over the individual pairs, then that will be F/UTP. You can often look on the side of the cable to understand how things might be configured on the inside without having to strip any of the wires back. For example, this cable has S/FTP written on the cable itself, which means there's a shielded braid around the entire cable, and then each individual pairs of cables has a foil shielding around those. That's where we get the braided shield/foil twisted pair. There are a number of different groups that set standards for these network cables that we use. One of these is the EIA. It's the Electronic Industries Alliance, and they set a number of standards for the industry. You can see their standards starting with an RS or an EIA, and you can see all of their standards on their website at eia.org. Another organization that sets standards is the TIA, or the Telecommunications Industry Association. One of the larger sets of standards that we use for cabling is the EIA-TIA 568, which is the Commercial Building Telecommunications Cabling Standard. And international standards would come from the ISO/IEC 11801 cabling standards that set standards for everyone in the world. Not all twisted pair cables are the same. Some twisted pair cables use a different type of copper, some will use a different number of twists, and a cable may be shielded or unshielded. There's a set of standards that specify the minimum category of cable that you need to be able to send a certain type of signal. For example, Category 3 is one of the older types of category cables that you may still see in many organizations. That's designed to support 10-base-T or 10 megabit Ethernet, and it supported that over a distance of 100 meters. There's also Category 5 cable that supports 100 base TX and 1000 base T for 100 and 1000 megabit communication, and it can support those over 100 meters. Both Category 3 and Category 5 are no longer available. Usually the minimum type of cable that you'd see available is Category 5E, and the E stands for Enhanced. There were minor changes between Category 5 and Category 5E, and you'll notice that we support exactly the same Ethernet standards over both Category 5 and Category 5E, and Category 5E does support gigabit Ethernet up to 100 meters. When we increased the speed of Ethernet to 10 gigabit over copper, we created the 10G base T standard, and Category 6 cabling can support 10 gig over copper from 37 to 55 meters in length. If you're using Category 6A, which is an augmented version of Category 6, you can support this 10 gig over copper up to distances of 100 meters. And Category 7 is a relatively new category for twisted pair cabling. It adds stricter specifications for crosstalk, and individual wire pairs are shielded along with the entire cabling being shielded. It also supports 10 gig Ethernet up to 100 meters in distance. In our homes and businesses, there's usually a ceiling, and above that ceiling, we might have air supplies, and this is where we would also run our network cables. If there are air ducts that are providing the air for your air conditioning and also air ducts that are returning the air, that means there is a non-circulating airspace or no plenum above your ceiling. But in many environments, there may be air that is being supplied through air ducts, but the return airspace is going into a shared area where you have all of your building air circulation along with all of your cabling. This area is called the plenum. There are a number of fire regulations associated with this plenum area. That's because if there is a fire, this open area will be providing air to help feed any type of fire that may be in the plenum. You also have to think about what you're putting in the plenum and how it may react to fire, especially giving off types of smoke and any type of toxic fumes. So if you're running cabling inside of your plenum, you have to make sure you're using the right kind of cabling. A traditional cable will have a jacket around it made of polyvinyl chloride, or PVC. If you're putting cable in a plenum, you may want to use a fire-rated cable jacket. This is one that is made of fluorinated ethylene polymer, or FEP, or it may be a low-smoke version of PVC. PVC is relatively flexible. You may find that some of the fire-rated or plenum-rated cable may not be quite as flexible as the other types of cables that you're using. If you're planning to put anything in an area where there could be a concern with fire, then you'll probably want to use a plenum-rated cable. Although twisted pair is a very common form of network cabling, we also use coax cable for some of our copper cabling. Coax has a wire conductor right in the middle of the cable. This coax cable has insulation around that conductor, metal shielding around that, and finally a plastic jacket to protect the entire cable. If you're bringing in television or an internet modem, then you'll probably be bringing in RG6 coax cable. If you're working in a smaller area, you may be using RG59 as coax cables. These are not designed to be used over long distances, but they do make very good patch cables.